We're going to get granular. I'm an environmental engineer by training. I actually been working in California for 30 years. My excuse for being here, aside from Richard's kind invitation, is that I did my training at the University of Houston. I wore my Texas tie, so don't consider me entirely an outsider. But I'm an engineer, so my slides are all very text dense and impossible to follow. And we're going to get granular. I spent about 20 years managing a water utility in California. In Silicon Valley, our water recycling program. And for the last 6 years, I've been working with major companies developing industrial reuse programs. So I really appreciate this meeting because it's bringing capital and the business energy into developing water treatment technologies that can be used by these end users. And so we're going to look at it from the end user perspective. Like I said, we're going to get granular here. Hopefully we won't get lost. We'll still be able to see the forest after we wander through these trees, and I'll rely on Trevor to help bring us back to the other side of the forest, and then we'll maybe have a little time to talk about the journey. So the news is that there is a tremendous untapped potential for sustainable water use, that conservation, reuse, all of these are elements of sustainability, which is, I'll discuss in a moment, is an inevitable direction, but it's one that we can help accelerate. The drivers have to do both primarily with supply chain reliability, which is important whether you're a municipality or an industry, as well as long-term economic benefits. The economy as a construct, if you will, has a long-term perspective that is dependent on the underpinnings of the physical environment. You can have short-term growth if you violate the laws of sustainability, but if you have an unsustainable natural system, ultimately it will be non-economic. As Herman Daly, For the Common Good, an economist who talks about environmental issues, pointed out, that if your cost-benefit analysis suggests that the survival of the human species is not cost-effective, perhaps you should review your assumptions. So the idea is, long-term, it's going to be economically beneficial. The challenges are many. We've talked about some of them. We're going to talk about some more. They range from the corporate level to having the proper vision to align the goals of the C-suite with the factory, if you will, the boardroom and the boiler room, as well as the difficulty, and this is where I do a lot of my actual day-to-day work, customizing treatment to specific applications, because there isn't one size fits all. There's not a plug-and-play technology that you can bring to any factory in the world and have their water treated for its appropriate sustainable reuse. There's a lot of hands-on work. That's a challenge. And then, of course, the issue with the, as I mentioned, the economics and a cursory ROI that does not reveal the true value of sustainability. Ultimately, however, we have solutions. Corporate social responsibility is one of the trends that's moving in that direction, as well as full cost accounting. So that's the message. If you sleep through the rest, that's what I wanted to say. The gist here is that you can take, from an engineering perspective, water of any quality and bring it to water of any other quality. You can take the most gnarly, nasty municipal wastewater or the toxic industrial waste, and you can make it pristine to where it can be used for anything. It takes time and money, and that's where, of course, the trick is. My good friend Dave Sedlak, University of California, Berkeley, wrote a book I absolutely recommend to everybody, Water 4.0. Water 1.0 is bring the water to the cities for the Roman aqueducts. Water 2.0 is maybe we should treat the water so we don't all die from it. Water 3.0 is maybe we should treat our wastewater so we don't die from the water we drink downstream. Water 4.0 is let's look at the water system. So I won't go into detail, but this is the direction we're headed. We've done a lot of work in California. There was a 5-year program that resulted in a report to the legislature, commercial, industrial, and institutional water best management practices. And all this stuff is online, and the slides are available, so we can go into details. This came out because Governor Schwarzenegger at the time had the 20% by 2020 reductions for all across the waterway. Said we're going to reduce water use throughout California 20% by 2020. And people in industry said, well, if we do that, we're going to be reducing our revenues by 20% and your tax base by 20%. Are you sure that's what you had in mind? He said, well, instead of mandating it, maybe we'll come up with best management practices, a much smarter approach. That report looked at all industries across the board and found out while there was a tremendous potential for reuse and conservation, especially in cooling, also in processes. You can see some of these processes, some of these water uses are consumptive, many of them are not, and when a process use is not consumptive, when there's water left over, you can reuse that water. Again, from the ground floor, these are the opportunities that we're trying to take advantage of with appropriate treatment and control technology. So the BMPs came out with a report, they looked at all these different industries, and in every case, there were potential advantages for savings and reuse, everything from cooling and process to cleaning, sanitation, all the ways water is used in business, there were improvements that were possible. The drivers have to do, in many cases, with the fact that if you don't use water more effectively, it's going to impact business. The best example in terms of supply chain reliability, I don't know, is there anybody from Dow Chemical in the audience? Dow Chemical down at Freeport, I think that's the largest chemical plant on the planet. And back during the heart of the drought, about 5-6 years ago, they were told by the little city of Freeport they're going to have to reduce their water use by some 15-20%. To which I believe the conversation went something like that. Excuse me, we're Dow Chemical, you're going to tell us that hundreds of thousands of employees around the world were going to cut back our water. They had senior water rights, as I understand, on the Brazos River, and so they exercised those rights and built 2 reservoirs, 2,000-acre, not acre-foot, acre reservoirs, filled them with the water, came to an understanding with the Nature Conservancy to protect the wetlands from those withdrawals, and then took every drop of the 3 million gallons a day that came out of Freeport's wastewater plant. And that was done on the private sector side. So they took their supply chain responsibility very seriously. This is kind of new to us in developed countries. When you go to a developing country, you kind of expect to have to maintain your infrastructure and build your water system by yourself. But we're seeing that industry is taking a more proactive view of their own water supply reliability here in the States. Water quality stressors, if water quality changes or is unreliable, there are actually advantages to reusing water. And then similarly, there's a long-term ROI that provides an advantage. I'm not going to go through all these details, but this was a study that was done by the Water Reuse Research Foundation. It's now the Water Environment and Reuse Foundation. It was done to look at potential for on-site reuse of water by industry, taking their own water, treating it on-site and reusing it. And what were the opportunities and the obstacles to that, and the directions for research. And they came up with a great number of drivers and opportunities from the corporate side, from the technology side, for example, the potential for going to zero liquid discharge in certain industries is tremendous opportunity. From the facility side, cleaning in place. Again, the idea is that there's a lot of drivers within every industry. These came out of workshops. There were 10 representatives from 9 different industrial sectors that met for 2 days to go through what were the drivers that were encouraging them to reuse water on site, what were the things that were enhancing it. Came up with a lot of challenges, you wouldn't be surprised. One of them is the poor translation of corporate innovations into practice. And again, this is that conflict between the boardroom and the boiler room. The boardroom says, we're sustainable, we're going to recycle, we're going to be the greenest company. And the boiler room says, okay, how are we going to do that? I said, well, we're going to reuse our water. I said, well, if we take that water and we reuse it, it's going to have a higher chloride concentration. It's going to put pinholes in our admixture metals because of the nitrates, and then we're going to shut down the facility for a month. And then the boardroom says, oh, well, maybe we shouldn't do that then. So the actual implementation of green business practices is tricky. And that was identified as one of the obstacles. So there are a lot of challenges here. Financially, the insufficient ROIs. Again, I do a lot of work with industries, and I say, well, is it cost effective for us to reuse water? Because the water is so cheap, and I know you've heard this from a number of other speakers, that we just can't justify it based on the market price. And a couple of things. First of all, the full cost accounting of water, and many of you are familiar with that. Once you heat water and you treat water, it's a more expensive water than what you bought from the utility, and if you can reuse that, you have a cost savings. And then in California, I get to ask them the question, what do you think the chances are in the next 10 years you're going to have another drought and going to be asked to cut back your water by, say, 20%? How much is it going to cost you either to reduce your production, find an alternate means, change your line, or change your treatment? So if you do something up front, and by the way, the answer to those questions is not zero. There is a chance, and it's going to cost. So So it's almost like from an actuarial standpoint, you figure what's the value of that? And there is a dollar value that you can then add to the overall perspective of developing a sustainable water program. Just one example from that research that was done by the Water Reuse Foundation. They looked at why companies do on-site reuse, and they said one thing happens is when their cost of treatment based on regulation reaches the point that the water quality is good enough to reuse, they will move in that direction because it just kind of makes sense. So that's not a highly analytical result, but you've got clean water that you've just treated because you can't dispose of it if it's not clean, and then you look at your production site and say, I have a need for water, but that's good enough, let's reuse it. And interestingly, they came to the further conclusion that cost was not cited by any of these workshop attendees as the driver. That in fact, the low cost was really a disincentive to reuse, but that it was that point where the water qualities matched. So it's really more from a treatment perspective. Looking down the road, I think the enthusiasm for investment in treatment and technology is shifting. I started out working in the public sector some 30 years ago, and I think that's where the locus of enthusiasm was. Most of the energy for water and wastewater treatment and reuse was driven by regulation, driven by the public sector. That's changing from my experience. The money going into the government has sort of decreased, but the identified need on the private sector side has increased. And that's where there's an opportunity to maybe find some common cause. Also, in private sector companies, you see a lot more opportunities for innovative things like zero liquid discharge. And we can maybe talk about that more, how to harness the impetus for investment on the private sector to compensate for the glacial pace and the slowness of adoption of new technologies by the public side. Maybe public-private partnerships are where. Some of the other economic trends, I think you will see the perfect point about the investment in potable reuse. We're seeing that all over in California now. And as you mentioned, the direct potable reuse binary here in Texas, we're seeing, I know, at least 3 projects in California now. Much more investment in industrial reuse, and especially on-site wastewater treatment and reuse. And I think we're going to see more efficient local and regional systems. This is really facilitated a lot by the new technologies, membrane technologies, a lot of decentralized technologies that make it easier to scale treatment and reuse at different levels. And I think because of that, we're going to see more integration. And then the flip side, from the analytical perspective, we're going to have a lot more emphasis on detection methods and then software analytics for running these more complex distributed systems. So just a picture from the urban metabolism, looking at water and materials and energy flowing through cities. The more we adopt holistic views of our water, energy, materials usage as a community. We have 7.5 billion people on the planet. We're on a trajectory to get to 10 billion by the end of the century. These problems are not going to get easier to solve, and they're not going to be solved in a more monolithic way. We're going to have to take a more granular, distributed, decentralized approach, come up with more innovative solutions. And I think it's the people in this room who are going to help make these happen. So thank you for your attention.